Hello everyone and welcome back to another session in Data Science and AI lecture series by PostNetwork Academy. I am Bindeshwar and today we will dive deeper into the axiomatic approach to probability. Our focus will be on providing two important probability equations and solving related examples. So let's get started. So first is that probability of A intersection B complement, that would be equal to PA minus PA intersection B. This formula expresses the probability of A occurring without B. It uses the complement rule and properties of set operations. Let us see the proof. So the event A can be partitioned into two disjoint sets, and I am showing you through the Venn diagram. So if there is here set A and here B. Let us erase this part. So here if a element A contains 1 and 2 and B contains 2 and 3. So I am writing here A 1 and 2 and B 2 and 3. So here just I want to show that this you can write like here A intersection B. From the diagram just see that A intersection B is 2, and let us find out A intersection B complement. So see from the diagram A is 1 2 and B complement, and one more element I want to take 4, that is not in A or B. So A is 1 and 2 and B complement, if you see that, to except 2 and 3, that would be in B complement. So B complement would be 1 and 4. Now if we take union of both, so we should get A. So here we will get 1 and here I will get 2. So union of A intersection B union A intersection B complement, and you can see that is equal to 1 2, this one and this one. So that is equal to A. So that means A can be partitioned into two disjoint subsets. The first one A intersection B and this one A intersection B complement. And so I have proved that A can be partitioned into two disjoint subset using this example. This is universal set and this is B. I have written here. So this is B, A universal set, 4 is out of A and both B. Common element is 2. So I have proved that. Let us move further and prove the formula. So here using the additive property of probabilities, PA is equal to P A intersection B plus P A intersection B complement, and just transfer PA intersection B complement in the left side. We will get PA intersection B complement is equal to PA minus PA intersection B. Let us see the same type of statement. Here PA complement intersection B is equal to PB minus PA intersection B. It means that probability of B occurring without A. So again I am just drawing because it will require the skills of set theory. So you should be very good at set theory while you are learning axiomatic approach to probability. So again I am taking two sets or set of events. A, it contains one. Just if you want to take example, so just take 1, 2 as common, 3 as 2, 3 as B, 1 and 2 as A. And thereafter this would be universal set and 4 outside. So here see that it is actually asking that okay, so this one is I will draw in the next slide because in proof I will draw. So we will see here how to prove it. Here I will draw again. So event B we will partition into two disjoint subsets. The first one is A intersection B and second is A complement intersection B. So here what I was explaining I am going to draw. Here it is universal set A and there should be common set B. 1 common is 2, that is 3 and outside 4. So here A intersection B, you can see that A intersection B, that is 2, and A complement, here you can see that A complement, that would be 3 and 4, and B we have already 2 and 3. So in A intersection B you have got, let us see A complement intersection B, and that would be equal to 3. So you can see that A intersection B union A complement intersection B, that is 2, 3, and that is equal to B. So we have partitioned B. Let's write here B is equal to 2 and 3, and this value will also be 2 and 3. So let us use this concept and prove the formula. So let us take it further. So here, using the additive property of probabilities, so PB is equal to PA intersection B plus PA complement intersection B. Now just transfer or rearrange, you will get the formula. So these two are very important. Now let us see an example. So given that PA is equal to 0.6, and P A intersection B is 0.2. So here we need to calculate this one, P A intersection B complement C. So here we will keep the values PA 0.6 and here I will subtract. So it would come 0.4. Let us see. So here 0.4. Now second example, that is also very easy, and just plug the values. So we need to find P probability of A complement intersection B. So just plug the values here, PB 0.7 minus this one is 0.3, so obviously 0.4. Let us see that I have calculated it, so you can see that. Now hope you have understood these concepts. These are simple and very important topics in probability. For more resources you can visit website www.postnetwork.co. You can visit YouTube channel for videos and playlist. You can also visit Facebook page for posts and videos, and you can also connect to LinkedIn page of PostNetwork Academy. So hope you understood. Thanks for watching the video.